Hey everyone. So a while back in March, we gave this talk and demo about test-driven development or TDD. It's an introduction to the whole concept and the basics of how we do it and why we do it. And afterwards, a few people came up to us and said, "Hey, that was a really, really good presentation. You should do this online. You should record this and share it." So here we are. And this is going to consist of a few slides at the start talking about TDD, and then afterwards we'll show you more of a practical demonstration of doing some very, very simple problems with TDD. Now, before we even get into TDD, let's talk about the first principles, or let's just talk about some things that'll help you with writing better tests in general, which you really need as a foundation to practice TDD well. So, the first principles are a number of ideas about testing that'll make your tests a lot easier to use, a lot safer, a lot more reliable. So, the first one is that they should be fast. That's pretty straightforward. If you notice that your tests are running slower than they really should be, take a good look at why. You might have problems related to debouncing and async and other sort of pausing operations that you can find ways to solve or speed up your tests. It makes it a huge difference having fast tests. Being able to get that feedback really quickly is has a huge difference on your productivity. Your tests should be isolated or independent of one another. So you should never, if you've ever been in a scenario where you run a test in let's say a test suite in a certain order, and the test results are different to if you run them in a different order, that's a problem, right? That means your tests aren't isolated. That means the result of some other test is affecting your test. That should never ever happen. You should go to lengths to make sure that your tests are completely isolated from one another. They can't affect each other through any shared state, because when you get into that state where that does happen, it's a really confusing spaghetti mess of a problem, and it's worth investing time in making sure your tests are properly isolated. Your test should be repeatable, so it shouldn't be any random elements affecting the outcome. You should be able to run your tests 100 times, 1,000 times, a million times, and always get the same result every time. They should be self-validating, so you shouldn't have to put any manual effort into validating the output of a test. It should simply tell you, automatically when you run a test, either yes or no, this has succeeded or this hasn't. You shouldn't need to copy the results into a spreadsheet and go through this and that trying to figure out, oh, is this a good result, a bad result? What does this tell us? The test should just tell you if it's passed or not. And they should be thorough, right? So you don't want to just test the happy case for one most immediate obvious thing. You should also check for validations and edge cases and make sure you're actually testing the whole problem. There's also the arrange, act, assert. This is sort of a way of working that'll simplify how you write tests and make it a lot easier. So the basic idea is to arrange the context of a test first, then have just a blank bit of space, then perform the act that you are testing, and then lastly, assert the result. It's a very, very simple thing, but if you consistently follow this practice, then you'll find that your tests are much better standardized, they're much easier to read and understand, and you can immediately figure out what's going wrong much more quickly when you look at a test. So this is a very simple example. We've only got one line for each, but as I'm sure you can imagine, if you've done much testing at all, the arrange step in particular has a habit of becoming much more complicated. So this might have several different dependencies that you need to arrange in the right way for the context of your test to be ready. Then you act on the thing you're doing, and only then do you assert. And your assertions, can sometimes get a bit more involved as well. And it's important to have that distinction and make it clear that, okay, immediately I can look at this test and say, oh, there's the setup, there's the thing that's actually being tested, and there's the assertion we're making afterwards, right? Really, really simple. Now, another thing to understand is unit testing. We're not going to go into depth on this, but it's important to understand the benefits of unit testing. There's a lot to be said about unit testing and integration testing and when to do one versus the other and the benefits and drawbacks and so forth. I'm not going to get into that in too great a detail, but the broad principle of unit testing is quite demonstrated quite well by this diagram that I've borrowed, credit at the bottom there. So you can imagine that your class you're testing, or let's not say class, let's just say unit of code that you're testing is in that green piece. And in day-to-day operations in production, it's interacting with so many other units of code that it may depend on, or they may depend on it in some relationship. And if you integration test, you're also testing all these other things at the same time. And for fast unit tests, you don't really want to be testing everything else around it, especially if those other dependencies have side effects, right? So by side effects, we mean things like writing a file to the file system, sending a message to a database, sending a message to some web service, listening for messages on a network. Anything like that becomes more complicated to test, right, at those boundaries, and you really want to exclude those if you can. And for async can complicate things as well. There's all sorts of reasons why, if possible, you want to isolate those other code units that you're interacting with, and ensure that you're able to just test the thing you're focusing on. And that's really easy to do with mocks, which allow you to essentially just take any one of these units of code and replace them with a fake test version that will allow you to just input whatever context you need for that particular test case. Now, what actually is TDD, right? So TDD is a sort of three-step process. You firstly write a failing test, then make the test pass, and then you refactor. Okay? So the very first thing you do, right up here, write your failing test using the same test principles we've talked about, keeping in mind that if a test doesn't compile, that's totally fine. You can just think of that as a failing test. You don't need to write the production code or the design of your software first. You can write your test upfront, even if the class, the function, the whatever you're referring to in the test doesn't even exist yet. And then you can go and make the test pass. Sometimes making a test pass can even just mean making it compile. And then we can go back afterwards and say, okay, so we've made the thing pass. How do we refactor this to actually be a bit cleaner? We also have these commit steps here. So I've added them here and here. I think it's definitely important to commit every time you make a test pass, and also after completing every refactor step. You can also commit here in between writing a failing test and making a test pass. There's nothing wrong with doing that whatsoever, especially if you're not on the main branch. So if you're on a feature branch, it's no big deal if you've worked a test on your feature branch for a while. You can commit a failing test. It's not the end of the world. But you wouldn't necessarily want to do it every time, so I've just omitted it from that particular point. Again, this diagram we've borrowed from another website credited down there. Now, the commits are really important because they give you something to fall back on, right? So this refactor stage here is a really, really powerful benefit of TDD, because I'm sure you've all had the experience where you think something's working just right, and then you go in and change a few things, and then you find, oh, it's not behaving in the way I thought it was, or something's wrong. And you start to question, oh, well, was the thing I thought was working before actually working? Is this a different case? Was it something like before, or have I broken that by changing it? And you just get lost in between the different possibilities and what's happening. So the combination of a refactor step and commits and the testing TDD gives you this great benefit that if you ever get into a situation where, something I thought was working was not working, you know for a fact that the last time you made a test pass and you committed, all the tests were passing, right? So you know from that moment it was working fine. And you know without a doubt that since that last commit, whatever changes you've made since then have broken it, and you can clearly identify what the changes are that are relevant, right? So this is a huge benefit, giving you a kind of safety net that whatever you do, you know you've made very small steps using TDD, using tests all along the way, and you've committed every time you've got a test passing. So you're able to just refactor and change things freely. You don't need to worry about breaking things. So long as you follow the guide closely, all you need to do is make your test pass, commit, and then you can radically change the entire code base as much as you want. Go crazy, because at the end of the day, the tests will tell you if anything's wrong. And if anything is wrong, you can just revert your changes and go back to the previous working version that you committed 5 minutes ago. So it gives you huge confidence in refactoring. That is a really, really big boon I think a lot of people aren't used to. Anyway, let's go over the actual sort of strict rules of TDD, which are these three steps here. You are not allowed to write any production code unless it is for making a failing unit test pass. You are not allowed to write any more of a unit test than is sufficient for it to fail, keeping in mind again that a compilation failure is a failure in itself. And you're not allowed to write any more production code than is sufficient to pass for one failing test you have. It's always very tempting to go beyond and start implementing other things you know will probably be necessary, but it's really best to leave that alone and write the test first and not go getting ahead of yourself until you've written the next test. And lastly, for refactoring, we have rule of three, which says that you should extract duplication only when you see it for the third time. So if you see something coming up twice, if you see a similar bit of logic in two places, don't go overboard right away and start extracting it out and saying, "Oh well, I'll do a refactor step here and I'll deduplicate that." You'll find yourself possibly doing that far too much, and wasting effort if you do that. The rule of three is designed to, and that only as a guideline. You don't have to follow it super strictly, but the rule of three is designed to help you know when to actually start doing refactors and when to start worrying about deduplication. So these guidelines, I definitely recommend following them very closely if you're starting out on TDD. But overall, they are just guidelines, right? Once you have the gist of it down, once you understand what's happening and how to do TDD, you don't need to follow these to the nth degree. You can bend the rules here and there, you can break them, you can do what you like. But to start with, if you're a beginner, try following the rules closely and see what you find. So there are a few steps when it comes to implementing something in TDD when we're following what we call simplest implementation, right? You should always aim to do the simplest thing first. The guiding idea behind TDD is not just the tests, which are obviously an important part of it, but really the guiding idea behind it is making very small steps, having very small iterations in your code, and having very fast feedback loops because of it. So, in order to make these very small steps, when you are doing your implementation phase, once you're making your test pass, you should pick the simplest possible implementation you can. Even if, sometimes the simplest implementation you can is something that's borderline useless for an actual production case, that's totally fine. You're in development. You're not about to pass this off to your stakeholder and say, "Hey, I've just hard coded the answer for one use case. Will you ship this?" You're just in development and you're making small steps. Solving one little use case at a time. So often, the very first thing you'll do is to create a fake implementation where you just hard code exactly the value needed to pass one test, and that passes a test, and that's totally valid. The next thing you can then do is add another test that won't work with a hard coded result, and that forces you to then be like, okay, well, I need to actually write some kind of logic in here to pass both these cases. And then you can write what we call a obvious implementation, in which you just don't try to think too far ahead, don't try to be overly smart, just think of the most obvious thing you can do to get both these tests passing. And then, of course, you can do a refactor step if it's necessary to kind of design it in a way that you think will be a bit cleaner going forward, but start with the obvious implementation. Then, when you come to your refactor step, you'll have two passing tests that you both and for both of them are valid and correct, and those can validate your smarter, more optimal code once you come back and refactor it, right? From there, you want to triangulate for the following tests, yeah? So if you think of the problem you're trying to solve as a sort of space filled with the requirements of the test cases, there are different dimensions to these, right? Because if you start tackling another part of a problem, it can kind of introduce matching complications with the features you've already implemented. So, what we try to do here is to triangulate by adding new dimensions of this space, new test cases, one at a time into our tests, which forces us to then gradually grow that solution in complexity, right? So you start out with something dead simple, you add something also quite simple, but a bit more complex. Then you start adding new tests that make you need to make it more complex still, and just keep adding those new tests, gradually increasing the amount of space within the problem space that your tests are covering until your tests are covering everything, and your production code, by consequence, will also be covering everything, right? So why do we actually do TDD? What are the advantages? Well, one is that it forces you to design a good interface upfront, right? So this is particularly good with what we call outside-in TDD, but I won't be going into inside-out versus outside-in here. But the idea is that if you just go in and write the production code first, you're going to think about the design up front, and you're going to think about all the internals of the logic of what the code needs to do, and not necessarily about the interface. So maybe you've had that experience where you write a bunch of code and then you go to write some tests for it and you realize, actually, this is kind of awkward to use in the way I've designed it. So designing a good interface up front, following TDD, because you're writing the tests first, it forces you to think about, okay, how do I actually want to consume this unit of code I'm producing? How do I want to use this? How is my consumer who's going to be making use of this code, whether it's a library or a web service or just a class in some bigger project, whatever it is, how is it going to be used, and how can I best design the interface? That's the first thing you have to think about when doing your test, right? Because you literally have not even written the class, the interface, whatever it is, function first. You're calling it before it even exists within your test, and that makes you think about, okay, what would be a good design? It gives you a shorter feedback loop. So this is a really big benefit to productivity, as I was sort of hinting at before. There's no more waiting around. You don't have to say hand off your code to QA, or wait for CI to come back and tell you whether or not a big slow integration test has passed or not. Instead, you have lots of integration tests that you're working with locally, and you know if something's wrong immediately. So you don't need to context switch onto a different project and be doing something else, and then later find out that actually a thing you're working on earlier is now broken. And you have to context switch back, and then that all incurs a cost of trying to remember, okay, what was I doing again, and why is it broken? No, you just get immediate feedback right then and there, and you know right away what's gone wrong, within a few seconds instead of hours, right? And of course, that also allows you to catch errors earlier and sooner in the process. Another advantage is your frequent small changes. So by breaking this problem into these small changes like we're talking about, they are easier to reason about and understand. That's a really big part of this. You'll find that if without breaking things into small pieces, without using TDD, you may get lost in a bigger problem and lose track of, where did you start, where did you end? There's only so much kind of mental space you have in your mind, right? And if you can break the problem down into small pieces, it's so much easier to reason about and to kind of store the whole current problem in your mind at one time. And it allows you to write testable code from scratch, right? Because you're writing your tests first, your code is inherently designed to be testable. Any problems with the testability of a code, you're going to come across very quickly and you're going to solve it very quickly because you're writing the tests first, because your tests are covering the whole swathe of the problem space. And what's more, testable code is good code, right? The same attributes that make code testable also have a very strong correlation with good general software design principles like dependency inversion, composability, command query separation. All these things happen to cross over closely with what makes testable code. Just happens to be the same as what makes good code, and you're going to find benefits for your software design if you're testing it from scratch. And you always have a recent working change to go back to. So that's sort of a safety net I was referring to. You're able to confidently refactor, knowing that no matter what you do, you can just revert your changes and go back to a working version with a plethora of tests demonstrating that it works. It also provides documentation, right? Because you've been testing from the start, giving your tests good, clear names. All you need to do is print out the names of your tests, and that is your documentation. You can go over to anyone and say, here's what my code does. It's just this list of things here. All these test cases I've been writing since the start. Because I write a test for every single extra feature, extra validation, extra anything that I add, um, I have an entire list of everything my code does right here. And you also get high test coverage, right? So this is an interesting one because most people, particularly when they first hear about TDD, they think that this is the point. They think that this is the aim, is to get high test coverage, and it's not. So I very intentionally make this the last advantage I discuss, because it is an advantage. It is a valid advantage. There's a definite benefit to having high test coverage, and that's great, and I'm happy that TDD gives us that. But everything else we are talking about the confident refactoring, the improvements in the design, about the sort of safety net and the small steps and the reasoning about simpler units of a problem instead of going all in at once on this big whole problem, breaking it down into smaller pieces and having a very short feedback cycle. That is the point of TDD, and that's the real juice. Juice. That's the real the biggest part of the pie, biggest piece of the pie when it comes to what the advantages are, right? The high test coverage is a valid benefit, but it's not everything. So when we talk about the feedback cycle, I think this is a really useful diagram to discuss that. This is from Kent Beck. And it sort of talks about the speed at which different methods give us feedback, right? Now, Kent Beck says that optimism is an occupational hazard of programming, and I think we can all relate to that, right? What programmer, what software engineer has not had the experience where you turn around and say, oh, yeah, that'll take me a week. It's 95% done. The last 5% will take no time at all. And then it turns out that 5% takes far longer than you estimated, and it takes a very long time, right? So Kent Beck says to that, feedback is the treatment to that problem. And I think that's a really good point. With feedback, you can more quickly get an idea of, okay, what's actually happening, what's going wrong. Um, it's it's easy to get overconfident and think that you understand everything that's going on in your code. But when when you're following TDD, you have a whole suite of tests and you're getting this feedback really quickly, it gives you genuine confidence in actually knowing everything that is going on in your unit of code you're working on, right? So as an example of that, this diagram is talking about how, okay, if you're pair programming, you can get feedback in a number of seconds. So that's kind of a different discussion, not really relevant to this video, but also another important part of extreme programming. If you have unit tests, which is more of the approach we're discussing, then you'll get your feedback within a minute or two. And if you're isolating it to fewer tests, perhaps seconds as well. And then if you're doing, we're calling here, pair negotiations, so that might be, kind of peer review, then you might wait for hours to get that kind of feedback, right? And if you're going to bring something up at stand up the next day, you've got to wait all day until you can get any feedback. If it's a big acceptance test running in CI, you might have if you're at a big corporate, you might have thousands of these browser automation tests that can take days to get feedback back. Um, Whereas if you're actually following TDD, writing your unit tests, you're going to get feedback in no time whatsoever and close that loop and be able to just spin around this loop here in no time at all, being, okay, here's a problem, here's a solution, here's a problem, here's a solution, instead of waiting for these other much slower feedback cycles to get back to you and tell you something's wrong, right? So, a few principles that will help if you want to follow in this whole TDD journey. Tests should test one thing only, right? You should have one logical assertion. Don't make big complex tests. Now, we say one logical assertion because it doesn't necessarily mean you should only have one assertion line in your code. It's fine to have multiple assertion lines every now and again, multiple calls to assert equals or expects or whatever the equivalent is in the programming language you're using, but they should only logically test one thing, right? So, for example, if you're testing a result from a list, you might choose to check that it has the correct length and then check that the thing inside the list is what you expect. So that would be two sort of assertions in code, but logically you're just checking for one thing, which is that you're checking the thing you expect to see is in the list, right? And it's just faster, easier bit of feedback if you check the length first. And you should never refactor with a failing test, right? This is called don't refactor on red. So this is a really important principle. If you go refactoring when you don't have a passing test suite, then you're going to risk ending up in a really messy situation, right? You're basically crossing the wires. You're losing the benefit we're talking of earlier of having that safe fallback, right? If you're refactoring on red, then you don't know if your refactors are working or not. And you're probably going to end up having to refactor the tests as well. So you might also lose confidence in the tests you've written because you've never seen them pass, refactoring them for the first time. And if you have perhaps dozens of these tests affected by your refactor, well, make sure your tests are all on green before you do a refactor step, and it'll make your life a lot easier. Organize your unit tests to reflect your production code, right? So it should be dead easy to find your tests. Exactly how this is done changes quite a bit on whether you're using Java, JavaScript, Rust, different languages, different paradigms, a different way of arranging where you put your tests. But you should always arrange it in a way that's very easy to say, okay, if this unit of code is here, then the test for this unit of code must be over here, right? It should be painlessly easy to find the test given a particular piece of code. And that is going to make your life a lot easier as well. Another fun one is starting from the assertion. So this kind of turns your method of writing a test on its head. This isn't necessarily something you have to do to practice TDD or anything like that. It's not one of the rules at all. It's just an interesting guideline I tend to follow, in which you, before writing your setup, so your arrange or your act, you write your assertion first and sort of work through the test from the assertion backwards. So you're looking firstly at, okay, what am I expecting? What is the output I want in this scenario? Then you're looking at, okay, to get that output, how do I want to consume this piece of code, this unit of code that I'm designing? And then lastly, you want to say, okay, given I call it like that and I get this result, what setup do I need to ensure that this all happens? I think it's a really interesting way of designing a test that really makes you focus on the more important aspects first. And if your tests are difficult to write or maintain, consider changing the design. This applies both to the design of your test suite itself. You can absolutely refactor your tests. There's no reason that your tests shouldn't also be maintained and refactored regularly. and it can apply to the production code itself, right? If you're finding your tests are difficult to write or maintain, if you're finding that when someone adds a new feature or changes something, suddenly it's causing a lot of maintenance costs in your tests, or if you're finding in writing new tests, you're writing a lot of duplicated code you've had to write before, don't just put up with that. Think about ways to design either your production code or your test suite better that will make this easier to do, and it will pay off in the long run because you can be writing a heck of a lot more of these tests, and you want your test suites to be working really nicely, and you want your production code to be well designed and easy to consume, right? So the problem might be that there are problems with the design of your production code itself that is actually difficult to use and that's making your tests difficult to write. Or it might be that your test suite itself has areas where there are duplication and there are other problems where you could invest some time in deduplicating things and making it faster and easier to use, right? And that effort is always worthwhile. It's always going to be worthwhile. Don't even think twice about whether or not you can afford the time to do it. Just do it. So next, I'm going to pass over to Nacho, and he's going to give you a just accidentally changed slide. Next, I'm going to pass over to Nacho, and he's going to give you a demonstration on exactly how we practice TDD in the FizzBuzz programming kata challenge.
Hey, thanks, Mattsi. Hello, guys. My name is Nacho Gonzalez, and today we are going to be solving a kata called FizzBuzz, a popular kata called FizzBuzz, using TDD. Basically, the idea is to go over a couple of concepts that Mattsi mentioned before doing the presentation, and just have some fun doing TDD together. You guys can see the ID of choice is IntelliJ IDEA, and I will be using Java in order to solve the kata. Also, I have a repo connected to this project that you guys can find in here. And the idea is to use version controlling during the green and the refactor stage in order to commit the changes. And that's about it for the presentation. So now let's go ahead and talk about the statement of the kata. In case you guys don't know the kata, it's a simple system that will accept a numeric input. And if that input is divisible only by 3, the system will return fizz. If that input is divisible by 5, the system will return pass. If the input is divisible by both 3 and 5, the system will return FizzBuzz. And if it's not divisible by any of these numbers, it will return the number itself, the input itself. So as the first rule of TDD mentioned, we will need some test code before we actually jump into implementing main code. So I'm going to go ahead and create a test class. All right, and the reason I use should in here is because after this, whenever I create my test, I will start with a verb, and then I can actually put them together to construct a sentence that will represent the behavior I'm testing. So for example, FizzBuzz generator should, and then the name of the test will complete the sentence. Let's see an example with the first test. So for example, yes. But just before we actually jump into the name of the test, let's talk about how useful it is to split the problem into logical parts. So in this particular case, the problem, because of the statement of the kata, is pretty easy to understand and is quite well explained. We already see the behavior that we want to test straight away. So we can see, for example, that this is the first thing that we want to do, and then we want to jump on the next testing the next behavior and so on. So I'm going to start with the input only divisible by 3. In this particular case, let's go back to the name. So we can say, for example, if we think of a case in order to this behavior, the so now if we read everything together, FizzBuzz generator should return fizz if the input is 3. And I know what I'm testing. So after this, it's worth mentioning that tests usually are composed by 3 parts: the arrange, the act, and the assert part. In the arrange, we will basically prepare our variables. In the act, we will actually perform the action that will trigger whatever we need to test. And then in the assertions, we will recollect and test that the behavior is the correct. So After I name my test, I like to start with the assertions because I know what I'm going to test straight away. I can start with assertion and then go backwards in order to back up that assertion. So an example will be all right. So this is the code for the test. Let's run the test and check how it goes. So we're expecting some errors, mainly because this generator class doesn't exist. And this is why I complain. So let's go ahead. Now that we are in red, we now can jump into the main code and fix anything in order to get the first test screen. I'm going to go ahead and create this class. Also create this test or this method. And now it's not complaining. Let's run again and see what happens. Cool. So it's actually behaving the way we expected. It's expecting fizz, but the actual value that we return is null. So in order to make this work, we can start doing this. In TDD, we have three ways of going ahead, going forward. The first one is faking the result. The second one is the obvious implementation. And the third one is triangulation. In this particular case, faking the result is pretty useful because it's a pretty simple thing to do, following various steps, the easiest thing we can do. And now, if we run the test, we will see that we get a green. Cool. So now that we have our search screen, the idea is to go and commit the changes. All right. So now we will be in the refactor phase, because if we follow the rule of three, that basically what it says is it's not until we have 3 repetitions of the same thing that we can actually try to change it. And the rest of the code is actually readable. I'm pretty happy skipping this refactor phase and go ahead and do the second test for this behavior. Let's run this. So we have another green, and make this. For the same reason as before, pretty happy with the code, pretty simple, and we don't have enough repetitions to make any changes. So let's go ahead and try to tackle the third one. And this is the third case for the same behavior, which usually what happens is, for me, it's enough to actually try to change the behavior I want to test. This is good enough. But after the green, we can talk about a couple of refactors. So I'm going to commit these changes. All right, so this is committed. And for the main code, I'm actually happy. But in the test code, I can actually propose a few changes. So the first one will be to move this object generator into a setup. And what this is going to allow us to do is to delete this part and rerun it. We will alleviate a little bit the code, still getting green and fewer lines. So let's go and commit this. All right, so this is how it looks. So now, for example, we pay attention. We have 3 tests with 3 cases, different cases, but testing the same behavior in the same place. So that kind of invites us to think if we can do another way of making this more readable or alleviating this code. So one of the proposals that I have is to create a parameterized test, trying to summarize these three things into one test. And in here, we need to pay attention to. There will be cases that actually, for this amount of tests, maybe parameterizing is not good enough, because there are moments that we will pay more attention to the information that the name of the test gives us, rather than trying to choose the readability that parameterized test will give us, because it will be fewer lines of code. In this particular case, I'm happy losing these three explanations, let's say, or descriptions inside of the names of the test, because I can get a name descriptive enough in the parameterized test that will represent the same behavior. So let's go ahead. All right, so we have our parameterized test ready. Let's run everything. And all green. But just before I omit the code, I would love to get rid of the redundant code safely. So now that we know that this is correct, let's run it again. Oh, now, green. So let's go ahead and finish this. All right, so the refactor was successful. For the next one, I'm going to tackle inputs divisible by 5 only. So let's go ahead and create the first test. Let's run this test. And if it's because of the right reason. We are expecting buzz, but I'm getting fizz. So now what we can do is I can jump into the code and try to fix this. So following baby steps, the easiest thing I can think of is this. Right. So let's run everything. Cool, so we have another ring. Let's commit this. All right, so this is committed, and yeah, following the same reason I said before, I'm happy with the main code, and there are no enough duplication or repetitions in my test or anywhere else, and I'm happy with the readability of this, so I can jump into the next thing. That is the second test for this behavior. Let's go with, let's run everything. screen. So I can actually go ahead and say commit this. And for this refactor phase, same thing. I'm going to skip it because I'm happy with the code. So I can tackle the next one. The next one is going to be number 20, because if we take into consideration 3 and 5, 15 is divisible by both of them, but 20 is only divisible by 5. So I'm going to run this. All right, so this is green. I'm going to commit this as well. And now that we are in refactor, main code, I'm pretty happy with it, but for the test cases, I'm going to actually propose to have another parameters test. Let's run it. Cool, so we have another green. Just before we commit this, let's safely delete this redundant code and just run the test again. Right, this now work. Okay, cool. Okay, so this behavior will be tested. Let's jump into the next one that is divisible by both 3 and 5. So let's create the first test for this. So let's run all the tests, and we're expecting an error. Yeah, so we're expecting FizzBuzz in the last test, but we're receiving buzz. So now let's jump into the code and fix it. Following the steps again, the easiest thing I can think of, for example, is I can add another condition, and then I can clean and take care of it later if I think it's if I can refactor it. But for this moment, I just need to commit it pass. Great. Let's run everything. Green. So I'm going to go ahead and commit. All right, so now so far I'm pretty happy with the code, both in the main and the test dimension. So let's go ahead and create the next test. And run. Bing. Let's commit this. And same thing, I'm going to skip this refactor phase, and I'm going to try to reach the third test. And in here I'm going to try and do for let's run this. Bing. All right, so let's commit this. And now in this refactor phase, we can actually create another parameterized test for the divisible by 3 and 5 behavior. In here we can go with in 30 and 45. And this divisible by 5. Oh, that's not this. All right, let's commit the changes for this refactor. So in here, I'm looking for by 5, 1, 3. Cool. Actually, I forgot to, because we're still in refactor, I can actually do it. I forgot to clean this redundant code, and I'm going to do it and say, cool. So now we are ready to actually tackle the last behavior, that is inputs not divisible by 3 or 5. Do the first test. All right. Here this. So return 1 if 1 is input. Let's run this. All right, red. So let's try to fix this problem. The quickest way I can think of is I can add another condition here. Doing this, and here, string. So let's try this. All right, green. So this is the behavior we were looking for. Let's commit this. And now we are in the refactor phase. So for example, in the main code, I can think of another change or refactor that I can do to alleviate a little bit the code by getting rid of one condition. And here it's like, for this particular case, I can go and say empty. All right, so let's run this. Okay, so this is working, and now we can say add. Okay, mentioning that I understand that there are a lot of possibilities and solutions for this problem. You guys can select the ones that you feel like. I'm happy with this one, and the purpose of the video is just to do some TDD together and not getting the best and most optimal solution. Apart from that, noting that in here, apart from 2 conditions, we have temporal coupling. That is one of the type of couplings that exist, in which if we actually change the position of this and we run our test, at least one of them will fail. But knowing this, I'm happy with the way it looks and the solution. So let's go ahead and focus on the process rather than the solution. I'm going to run everything again. so that will be ready here, and now that refactor will be finished. So we can jump into the next test. Let's run this. Bing. All right. Cool. So for the same reason, pretty happy with this so far. No refactor needed, and the tests are alright. No repetitions of everything anywhere. So I'm going to go ahead and do the last test for this behavior. Will be on this. Cool. So another green. Let's go ahead and commit this. All right, so we find ourselves again in another refactor, and the ones that I can actually propose is another parameterized test in order to take care of the last type of behavior. So let's go ahead with 1, 2, and 4, and in here return input if input not all right, so let's run everything again. Cool. And let's get rid of the redundant. Run everything. Cool. So this refactor was successful. Let's commit these changes. All right, so that will be push. Okay, so this is how our tests look, and this is how our final code looks. All right. So before we actually finish mentioning, it's worth mentioning that, as you guys can see, the test can actually act as a safety net. So because now if me or anybody else makes any changes into the main code, we can actually have the possibility of running our test and check if everything is all right or anything is broken. And as you guys can see, another thing is the more tests that we've been grading, and the more specific we get in our test, the more general our main code gets in order to adapt to all those cases. So this is the end of the kata. I hope you guys like it. Thanks for watching, and I see you in the next one.